This is Pipesim Python toolkit for beginners. In this video, I'll show you how to run network simulation task. And what's the most important, I'll explain how to read results. Let's start from case study model. For this video, I use the model CSN301 small network, which is located in the folder network models. If you open this model in user interface, you will find the small network, which contains the source, well, and two sinks. I'm focusing on network simulation task, so let's open the task window, and we can see that the boundary conditions are defined. This network simulation task is configured to run with reservoir conditions, and everything is ready and we can run simulation immediately. I will do it a little bit later. There is another one thing I want to show you, the studies. In this example, there is only one study. So we will not use the study when we run simulation in Python toolkit code, because by default, this study will be used. So let's go back to the code. If we want to run the simulation, we need to use the model object, then select class tasks and select the task we want to run. So I'm going to run network simulation. And here I have the method to run simulation, run. We can see that there are different arguments in this run method. So we may pass profile variables, specify system variables. If we want to override boundary conditions, it also can be done. We may pass constraints, select if we are going to use the surface condition as a boundary condition or not. Then the study can be specified. In our case, there is only one study, so I'm not going to pass it. And there is also additional settings for network simulation is options. I will cover it later. Anyway, in this example, I don't want to add any arguments. I just want to run this model as is with predefined boundary conditions. And while it's running in Python toolkit, let me switch to user interface and run the same in user interface, because I'm going to compare results with user interface. So I run the simulation in user interface, and now I need to wait a little bit while the simulation is finished in PTK. So the simulation is finished, and we can report the results. In the results object, we have, for example, the system. If we report the system, we can see that we have complex dictionary. The first key in this dictionary is the name of the property. So we can report the pipe outside diameter, and then we have values, which is ordered dictionary, and here we have the objects and the value of the objects. So if we want to print some value, for instance, system inlet pressure or maybe system outlet pressure, we need to use the following structure: system variables, system inlet pressure, and now I can see that under this level I have all components with values. So let's compare something. For instance, we have the system inlet pressure with source, and the value is 677. If we go back to user interface, we can see that this system is equivalent of the network node branch results with settings branch. So here we need to add variable system inlet pressure, and we can see that the source has the value 677. I want to remind you that this value was not specified, so this is a calculated value, 677. And let's check something else. For instance, for the well, we should have the value 2514. If we go back to this interface, we have this value, 2514. So the system, result system, contains information about node branch results and display mode branch. If we go to Python toolkit examples, we can find another way to represent this data. Let me open it. In the installation folder under the Pipesim version, we can find developer tools, Python toolkit, and here we have the folder examples with many different examples. I need to open the example network sim with information about the simulation. If we scroll down, we can find that there is a way to report the output in the pandas dictionary. So this structure is used to convert the output in the pandas dictionary. So I will copy this, go back to my code, I need to import the pandas object SPD, and now I can output the same result in the pandas object. So you may see that the pandas is used, and pandas is a little bit more useful because we have the name of the object as the column, and we have in the row the name of the property. So if I want to get information about the well, for instance, I will use this object, then I will use the name of my component, well, and I can find all possible parameters that were calculated for this well. If I want to report system inlet, I can use system variables and then system inlet pressure. Okay, so this is another way to report the data and get access to the data in the structured way through the pandas object. So let's go to another one result. So in the results we have node, and this is the similar structure where you have the parameter as the first key, and as the value we have the order dictionary with component name and values. We also can find the unit for this selected variable. So if we want to get information, we can go to node, then specify variable name. I will use explicit variable name, as we can see in this list, and for pressure I can find information. For the node, the value could be the same as we've seen in the system results, but they could be a little bit different. For instance, for the well, the value is 972. If we go back to the user interface, we can see that for the well, inlet pressure was 2500, but outlet pressure will be different. If we type here system outlet pressure, we can see that the value is not 900, so it's 675, and we need to switch to the node. In the node, when we select the well, this pressure out means the pressure at wellhead. So we have the value 972, and the same value is here. So if we want to report it another way, we can go back to example of network simulation code and then select the way to convert our results to the pandas object. So let me do it. Let me convert it to the pandas object. So I'm going to convert it, and now I have the structure. Again, we have the column name, the name of the components, and as a row name, we have the name of variables. So if I want to get some information here, for instance, I want to publish something for pump, and I have output here. As you can see, this pump contains pressure, temperature, enthalpy, and if we go back here, we can find that for pump we have the pressure, this is outlet pressure, but we may have something else. So for instance, there is additional variables here, for instance, efficiency, and the value of efficiency is 100%. So if I want to search it, I can do the following. I can type the node data frame, then I use the pump name, and then I can just say the keys. I want to know what's the key, and through this key I can do the search and find the name which includes efficiency. So let me do it for name and key. If efficiency in name, then just print name. And I see that there are two variables that includes the efficiency, for instance the pump efficiency. So right now I can use the node data frame. I need to search in pump object, and I'm going to get pump efficiency. And we can see that we extracted the data from this component, so 100% efficiency. In addition to the node and system, for network simulation we can get information about the profile results. So I will type the results, profile, and this output is different. As the first key we have the component name, for instance the gas sales, and then we have value which includes collections with the name of the property and list of different values. So if we want to get information, for example, about the gas sales, we need to set the gas sales first, and then we have a dictionary. So there is also example here in the network sim file where you can convert this output into pandas objects. So for each branch in our network, you can do the conversion to the pandas object. Let me just print this information. So the profile results for gas sales, and the information is here. And if you just expand this output, you will find information for other profiles. But I'm going to copy this piece of code, and I want to get information about the gas sales only. So I will set the results, then profile, and I will explicitly set gas sales. And this is my pandas object for gas sales. You can see that we have the horizontal distance, branch equipment, and all these details. So the output is similar what we can find in the profiled results tab. If I select gas sales, I can see similar table here with total distance, pressure, temperature, and all these variables. So let me just save this as a variable. I will call it gas sales, and see what I can do if I want to search something. I can use the column name to print information for selected profile or selected variable. For instance, I want to print information about total distance. So then I set total distance and print this information. I also can use the row number to print information at certain row. So for instance, I have this row number 13, and I want to print everything what I have as this row number. Then I can do the following. I can say the allocation and number 13, and then I have output for all possible properties at this row number 13. What if I want to do some search? For instance, I want to report data when the horizontal distance is equal to, for example, again, this value 90/20. So let me try to do it. First of all, I need to find this position. So for this, I can type gas sales. Then I need to type the name of this column. We have this, and I want to compare it with value 90/20. And we have this output with comparison results. And now I will use this comparison, and again call the gas sales. Now I use the function location and enter this as argument. And you see that I've done the search in my pandas object and reported the output at the depth equal to 90/20. So we have everything here. Using the same approach, you can do the search or more complex logic applied to this simulation. What else? I wanted to explain you details about options in the run method. Let me open Python toolkit help. You can find it in the installation folder, help index, and I'm going to do the search using the method run. Through the run, I want to select the network simulation run, and here you can find the description of all arguments, and I'm looking for example. In the example, we have example how to define the boundary conditions and all other details, but I need to find what's the option is. So the options I can set up if I want to generate file, if I want to use restart, or if I want to use this parallelism. So this option is used to set up the number of cores which we are going to use for parallel simulation. So I want to play with it. I'm going to copy this code, then go back to my code, and I want to run one more time my task. So I will set up the results, then model, tasks, network simulation, run, and now I need to pass some variables. So let me just reduce the output for system variables. I will set the system variables, system outlet pressure, for example. Then I will pass profile variables, and for profile variables, I think that profile variables pressure is enough. And for options, I can set simulation options. And now I will run the simulation. Let's wait the result. I expect that the simulation will be much faster than the first time, and it's only 5 seconds because I limited the output. And maybe this parallelism also affected to my simulation, but I really do not expect too many difference because the network is really small. The network is small. That's all what I wanted to share with you, and remember to close the session every time when you finish your code.